In August 1939, as the world stood on the brink of war, a letter landed on the desk of President Franklin D. Roosevelt. It was signed by Albert Einstein, and it contained a terrifying warning. German physicists, it said, had achieved nuclear fission. They were on a path to developing extremely powerful bombs of a new type. A single one of these bombs, Einstein warned, could destroy an entire port and its surrounding territory. The message was clear. The Nazis might get the ultimate weapon. America's response was slow, skeptical, and small. For 2 years it remained a tiny research program. Then, December 7th, 1941, Pearl Harbor. Suddenly, the impossible bomb was no longer a theoretical problem. It was a race for survival. But this race wouldn't be won by physicists alone. The science, while brilliant, was only the first step. The real problem was industrial. How do you take a concept that exists only on a blackboard and turn it into a weapon? How do you manufacture an element that doesn't exist on Earth? How do you build an entire industry from the ground up, an industry larger than the entire American auto industry, and do it in total secrecy? The man put in charge was not a scientist. He was not a nuclear physicist. He was Brigadier General Leslie Groves, a demanding, brilliant, and utterly ruthless engineer from the Army Corps of Engineers. Groves was a builder. He had just finished constructing the largest office building in the world, the Pentagon, in a record 16 months. He didn't know how to build a bomb, but he knew how to build anything. His first act was to approve the purchase of 60,000 acres of remote Tennessee wilderness. His second was to demand a blank check. The Manhattan Project had begun. The goal? Build a city, invent an industry, and produce a weapon. All before the Germans. And no one could ever know. Gladys Keeble was 18 years old, fresh out of high school in rural Tennessee. In 1943, she saw a classified ad. The government was hiring. Good pay, patriotic work, but it was secret. She was brought to a place that just a year before was nothing but rolling hills and farmland. Now it was a sprawling, muddy, chaotic city of 75,000 people, hidden in a valley. It was called Oak Ridge. It was the 5th largest city in Tennessee, and it did not exist on any map. Gladys was given a simple test, then assigned a job. She was led into a massive, noisy, windowless building, miles long, called Y-12. She sat on a wooden stool in front of a control panel with a single dial. Her supervisor explained the job. "Your only job," he said, "is to watch this needle. If it moves out of the green, you turn this knob to bring it back. You do not talk to anyone about what you do. You do not ask why. You just watch the needle." For the next 2 years, Gladys worked 12-hour shifts sitting on that stool, watching the needle. She had no idea what she was doing. She had no idea that the machine she was controlling was one of 1,152 devices called calutrons. She had no idea that these calutrons were the largest, most powerful mass spectrometrons in the world, giant electromagnets that were painstakingly separating uranium atoms one by one. The problem they were solving was this: natural uranium is 99.3% useless uranium-238. Only 0.7% is the fissile explosive good stuff, uranium-235. To make a bomb, you needed to get that 0.7%, and nothing else. It was like trying to separate two twins who weighed almost exactly the same. The calutrons did this by firing uranium particles through a powerful magnetic field. The heavier U-238 would turn just a tiny bit wider than the lighter U-235, landing in two different collector bins. The process was hideously inefficient. It would take months to produce just a few grams. But the scale of the operation was breathtaking. The magnets for these calutrons required thousands of tons of copper for their electrical windings, but copper was a critical war material needed for shell casings and wiring. So General Groves asked the U.S. Treasury for a loan. He needed silver. The Treasury official was stunned. "General," he said, "I don't know if we measure our silver in tons." Groves did. He borrowed 14,700 tons of silver from the Fort Knox vault, worth over $30 billion today, had it melted down and spun into giant electrical wires and bus bars to power the magnets. Inside Y-12, Gladys Keeble sat on her stool, keeping her needle in the green. She had no idea she was controlling a machine that was bending streams of uranium atoms through a magnetic field powered by more silver than all the treasures of history. Secrecy was absolute. Signs everywhere read, "What you see here, what you do here, what you hear here, when you leave here, let it stay here." Husbands and wives working in different parts of the same plant had no idea what the other was doing. They were told they were making synthetic rubber, or nylon, or just something for the war. They were told lies to protect the most expensive, most important secret on Earth. Every day, Gladys would go home, her entire body aching from the tension of just watching. She was a tiny, replaceable cog doing a mind-numbingly simple job, and she was, without knowing it, enriching uranium for the first atomic bomb. The uranium path at Oak Ridge was one solution, but it was slow, agonizingly slow. General Groves, the master engineer, was a fanatic for redundancy. He would not bet the war on a single, inefficient process. He needed a parallel path, a backup plan. The backup plan was an element that did not exist in nature, an element that had only been seen under a microscope: plutonium. Scientists theorized that if you put normal uranium inside a nuclear pile, a reactor, the uranium would absorb neutrons and transmute. It would, after a few days, become a brand new fissile element, plutonium-239. This was the new plan. They would breed their own bomb fuel. Once again, Groves went shopping. He bought 580 square miles of desert in Washington State along the Columbia River. He called it the Hanford Engineer Works. Here they would build the world's first industrial-scale nuclear reactor, the B reactor. It was a 2,000-ton block of graphite, 36 feet tall, pierced by thousands of aluminum tubes. Workers would push slugs of uranium into the front and cook them for weeks. But the reactor was only the first step. The real challenge came next. After the uranium slugs were cooked, they were now the most toxic, lethally radioactive objects ever created by humankind. A human standing next to one would receive a fatal dose of radiation in seconds. And inside these deadly slugs was just a tiny fraction of plutonium. They had to invent a way to get it out. This led to the most staggering and most secret part of Hanford, the chemical separation plants. They were called T plant and B plant. The workers called them Queen Marys. They were simply concrete canyons, two concrete structures 800 feet long, 65 feet wide, and 80 feet high. They contained 40 cells, separated by 7-foot thick concrete walls, and the entire process inside them had to be done by remote control. No human would ever enter these canyons, ever.
They built giant remote-controlled bridge cranes operated by men sitting in shielded galleries, peering through periscopes and primitive video feeds. They had to use these clumsy, robotic cranes to dump the uranium slugs into chemical baths, move them from cell to cell, and precisely extract the plutonium. They had to invent industrial robotics on the fly in 1944. If a machine broke, it couldn't be fixed. It was simply pushed into a disposal trench by another robot and abandoned. The Queen Marys were the world's first large-scale, completely automated, remote-operated factories. They were built to handle a material so deadly it couldn't be touched, to extract an element that had never existed before, to build a bomb that was still only a theory. And tens of thousands of workers built this place in the middle of the desert with no idea what it was for. By late 1944, the industrial giant was finally producing. The Y-12 plant at Oak Ridge, with Gladys and 20,000 other operators watching their dials, was producing grams of uranium-235. The B reactor at Hanford, operated by men using periscopes, was producing grams of plutonium-239. All these precious, priceless, deadly materials were shipped in secret convoys, in lead-lined suitcases, to the third and final secret city, Los Alamos, New Mexico. This was the brain of the operation. This was J. Robert Oppenheimer's laboratory. If Groves was the industrialist, Oppenheimer was the master chef. Groves was delivering the rarest, most expensive ingredients in the world. Oppenheimer and his team of brilliant scientists had to figure out the recipe. They quickly realized they had two different ingredients, which required two different recipes. The uranium-235 from Oak Ridge was stable. It could be used in a simple gun design. You just fire one piece of uranium into another, like a cannon. It would go critical and it would explode. They were so confident this little boy design would work, they never even bothered to test it. But the plutonium-239 from Hanford was the problem. It was dirty and unstable. The moment you tried to fire it like a gun, it would fizzle. It would melt itself before it had a chance to fully explode. It would not work. The entire $1 billion Hanford complex, the B reactor, the robotic Queen Marys, was on the verge of being a catastrophic failure. The scientists at Los Alamos came up with a desperate, brilliant, and seemingly impossible solution: implosion. If you couldn't shoot the plutonium, you had to crush it. The plan was to take a solid sphere of plutonium, no bigger than a grapefruit, and surrounded with 32 perfectly shaped, high-explosive lenses. All 32 explosives had to detonate at the exact same microsecond. They had to create a perfectly symmetrical shock wave traveling at 18,000 miles per hour that would crush the plutonium sphere down to the size of a marble. This sudden, violent compression is what would start the chain reaction. It was like trying to crush a beer can into a tiny pellet from all sides without it squishing out. They had no idea if it would work, and they only had enough plutonium from Hanford for one test. This was the gadget. This was the Trinity test. On July 16, 1945, in the New Mexico desert, they detonated the gadget. The industrial-scale reactors, the robotic factories, the 14 tons of treasury silver, the 75,000 secret workers, all of it came down to this one moment. A light brighter than 1,000 suns lit up the pre-dawn sky. A mushroom cloud boiled 40,000 feet into the atmosphere. The steel tower holding the bomb was vaporized. Oppenheimer famously remembered a line from Hindu scripture, "Now I am become death, the destroyer of worlds." General Groves, the engineer, had a simpler thought. It worked.
3 weeks later, on August 6, 1945, the B-29 Enola Gay dropped Little Boy, the untested uranium bomb, on Hiroshima. 3 days after that, Fat Man, the complex plutonium bomb, a copy of the Trinity device, was dropped on Nagasaki. The war was over. Back in Tennessee, Gladys Keeble heard the news on the radio. The president was announcing a new, world-changing weapon, an atomic bomb. And then the radio announcer said the words that made her blood run cold. It was developed in a secret city at Oak Ridge, Tennessee. She and the 75,000 other people in the secret city finally knew. Gladys looked at her hands, the hands that had done nothing but turn a small knob for 2 years. I was doing that, she later recalled. I thought I was just keeping a needle in the green. The Manhattan Project cost $2.2 billion, over $35 billion today. It employed 130,000 people. At its peak, it was using 1% of all the electricity generated in the United States. It was, and remains, the single greatest industrial and engineering feat in human history. It was a project of staggering genius, but also of staggering, terrifying industrial might. It proved that in the 20th century, the true power of a nation was not just its armies, but its factories. The bomb wasn't just invented by men like Oppenheimer. It was built in secret cities with borrowed silver, by robotic cranes, and by 75,000 ordinary people who had no idea they were changing the world forever.